Hi, and welcome back. So let's try another stoichiometry related problem. I'll actually scroll that up a little bit so it's, there we go. So let's try another stoichiometry problem. And in this problem, we are going to figure out, we're going to deal with this equation. So we've got the equation CaCO3 solid is going to yield calcium oxide solid plus carbon dioxide gas. And here's the question, and this is assuming I guess this would be our theoretical yield for this equation. So assume a 100% yield. But what we want to figure out is and this should be, that's a gas, sorry. What we want to figure out is how many grams of calcium CaCO3 we have to put into this reaction in order to produce 17.0 liters of carbon dioxide gas at standard temperature and pressure. So it's an interesting problem in that regard. So anyway, if you want to pause the video and try to do this now, otherwise I'm just going to start working on it right now. So the first thing, let's start writing down some information. So we know that we want to get 17.0 liters at standard temperature and pressure. So this is the big hint. And what do we know about standard temperature and pressure? How much space does 1 mole of some gas occupy at standard temperature and pressure? Well, it's going to occupy, I'll write this down in a different color. It's going to occupy, so 1 mole is going to take up 22.4 liters of space. So this is kind of the, I guess, the big, I shouldn't say hint, but it's a big part of figuring out this problem, is that 1 mole of any gas at standard temperature and pressure is going to take up 22.4 liters. So now we've got 1 mole, and I'll even write in 1 mole of CO2. And we know that 1 mole in this reaction we get for every 1 mole of CO2, that we produce, we had to put in 1 mole of CaCO3. So 1 mole CaCO3. Hopefully you don't mind. That's getting a little messy and condensed. And we know that, well, we have to figure out, I guess, is that 1 mole CaCO3 is going to be how many grams? Well, let's go. I'll scroll down and we'll get our periodic table and we will try to figure that out. So we have calcium. So the equation again, or the formula is CaCO3, and calcium is going to be, sorry if that's too small to see what the molar masses are, but calcium is going to be 40.078. And then we're going to have carbon, which is 12.011, so plus 12.011. And then we've got oxygen. So this was carbon, and now we've got oxygen, which is going to be 15.999, but we're just going to say that is going to be 16. And we've got 3 of them, right? So we're going to say plus 3 times 16. So now let's get the calculator out and figure out what our molar mass would be. So we have, let's start out with taking 3 times 16. So we have 48, we would have 48 grams of oxygen per mole of CaCO3. And then we're going to add 12.011. and then add 40.078. So this gives us 100.089 grams per mole. So I'll just go ahead. Oh, sorry, didn't mean to do that. So 100. So every 1 mole of CaCO3 is going to give us 100.089 grams. So now this is going, if we compute all of this, this is going to tell us how many grams we need, how many grams of CaCO3 we need to put into this reaction to get out 17 liters of carbon dioxide gas at standard temperature and pressure. So let's just get the calculator out. And once again, I'm not going to be computing, I'm not going to be multiplying or dividing by 1. I'm just going to start out with 17 divided by 22.4 multiplied by 100.089. And that's going to give us 75, and we've got 3 significant figures here, so it's going to give us actually 76.0 grams. So let me write that in. So this whole thing is going to give us 76.0 grams of CaCO3 is going to be required in order to get 17 liters of carbon dioxide gas out of this reaction at standard temperature and pressure. So anyway, that's the example. Hope you that was helpful. So I'll just keep doing more examples in the future. Thanks for watching.